Welcome, stargazers. Might you at any point accept it? Picture a heavenly event so enormous that it creates shaded areas on Earth, apparent even without trying to hide. That is the display we may be near, the precarious edge of seeing in the Orion constellation the star Betelgeuse, which is acting bafflingly, alluding to a looming cosmic explosion blast that won't illuminate our sky like ever before. But when will Betelgeuse go supernova, and what will it resemble? As per researchers, what privileged secrets could this heavenly event disclose? Join us as we plunge deep into the subtleties of what's actually the deal with Betelgeuse and the effect it could have on Earth, and maybe for the whole nearby planetary group, found roughly 650 light-years from Earth in the constellation Orion. Betelgeuse isn't simply any normal star, it's a red supergiant, one of the most luminous stars known to us, shining with a brilliance north of 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out for its brilliance, as well as for its history and significance in human culture. Named after the Arabic expression Yad al-Za'a, which means the hand of Orion, Betelgeuse has been noticed and recorded by ancient civilizations for millennia. It has been an aid for voyagers and a mark of wonder for stargazers, with its rosy tint recognizing it from other stars in the Orion star grouping. Can you imagine a single star predominating our whole nearby planetary system? To give some perspective on the sheer magnitude of Betelgeuse, if it replaced our Sun, its edges would stretch all the way to Jupiter. How could a single star achieve such epic proportions? At 10 million years old, it's much younger than our 5-billion-year-old Sun, yet Betelgeuse's gigantic size means it consumes its materials at a much faster speed, predicting a much shorter life expectancy than that of other stars. Now, this divine behemoth, crossing a volume large enough to contain more than 1 billion of our suns, is approaching the finish of its life cycle. When stars of such extent reach their dusk years, they don't disappear. They make a dramatic exit, a supernova blast that is beyond human comprehension in terms of its energy and brightness. Such an event can potentially eclipse an entire galaxy, casting shadows of brilliance across vast interstellar distances. The last time Earth saw a supernova blast this nearby was in 1054 AD, long before the development of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way system with the unaided eye, remaining visible for more than 1.5 years. It was brighter than any other star in the night sky and even stayed visible during the day for several months. What secrets do these heavenly remnants uncover to us? Ancient records from various civilizations, including Chinese and European astronomers, reported the appearance of this new star. Interestingly, remnants of this explosion, as an expanding debris cloud, can still be observed today with complex telescopes, providing us with insights into the violent ends of massive stars. Supernovae have been rare occurrences on Earth, but imagine for a moment a heavenly explosion so extreme that it rivals the brilliance of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event could charge our atmosphere, potentially affecting satellite operations and possibly even the climate. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for such a magnificent display. Could we be nearing one of the universe's most dramatic events? Just recently, astronomers made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable change that drew the attention of astronomers and stargazing enthusiasts worldwide. Known as the Great Dimming, the star's brilliance, which had been steady for centuries, started to decrease significantly. This sudden change was so noticeable that even casual stargazers observed it. When comparing Betelgeuse with other stars in the Orion constellation, it became clear that we might not be hundreds of years away from its supernova, but perhaps only a few decades, or even less. By April 2023, astronomical observations reported that Betelgeuse had returned to its normal luminosity, leading many to believe that the period of abnormality had ended. In an astonishing turn, the following months saw Betelgeuse's brilliance increasing by a staggering 50%. Such remarkable fluctuations, while typical of variable stars, were surprising for a star like Betelgeuse, which had predominantly shown predictable luminosity cycles. The sudden and extreme surge in its brightness pushed the star back into the spotlight, sparking discussions about its short-term future. But what caused this sudden change in brightness? Why did Betelgeuse, perhaps one of the most familiar stars in our night sky, suddenly throw a celestial curveball? Stars are not just shining dots in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For most celestial bodies, occasional brightness variations can be expected, akin to the rhythms of Earth's seasons. Throughout its celestial lifetime, Betelgeuse has maintained a relatively consistent 400-day luminosity cycle. However, with the Great Dimming, it seemed to defy its established behavior, testing our understanding of cosmic phenomena. Now, you may be wondering, are we on the brink of a heavenly revelation? While the exact reasons for Betelgeuse's inconsistencies are still under investigation, a compelling theory has emerged. This theory, focusing on stellar activity and mass loss, presents an intriguing scenario. Picture Betelgeuse as a titanic celestial volcano, subtly emitting and expelling vast amounts of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled a colossal amount of its surface material into the cosmos. This ejection, a significant event, was 400 billion times the mass typically released during comparable solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a dense dust cloud around the star, affecting its apparent brightness and temporarily making it more difficult to observe. Then, as this dust scatters or is driven away by the force of the star's radiation pressure, the veil lifts, which could explain its subsequent return to normal brightness levels. In any case, these new events suggest a star that is far from finished astonishing us. Many hypothesize that Betelgeuse may be approaching the twilight of its life, a supernova event, a breathtaking burst of energy that can outshine an entire galaxy in an instant. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or, in Betelgeuse's case, it may be due to the depletion of its nuclear fuel, which causes its mass to collapse into the core, paving the way for a cataclysmic breakdown. But what drives a massive star like Betelgeuse toward its death? Born from the gravitational collapse of gas inside subatomic clouds, stars like Betelgeuse begin their journey by fusing hydrogen in their cores. This initial stage, known as the main sequence phase, lasts for millions of years and forms the foundation of a star's life. But as stars run dangerously low on hydrogen, they expand, embracing new energy sources. In the case of Betelgeuse, as the hydrogen runs out, it begins fusing helium, leading to the creation of carbon and oxygen. This transition from the main sequence stage to the helium fusion stage is marked by the star's expansion into a red giant. Over time, as helium diminishes, the star undergoes further expansion and transitions into other fusion stages, each characterized by the fusion of progressively heavier elements. The greater the star, the faster these phases occur, due to the immense gravitational pressures at play. Then comes the climax, when iron begins to form in the core. Unlike lighter elements, iron does not produce energy when fused, so the energy released is no longer enough to counteract the star's own crushing gravity. The star swells in size, undergoes a collapse, followed by a massive rebound explosion, resulting in the violent energy of a supernova. So, is Betelgeuse near the precipice of a catastrophic end, or is it taking its time? Recent research by Japan's Tohoku University suggests that the star may be in its helium fusion stage right now, with some scientists believing the core could collapse within years as its carbon reserves run out. However, not all researchers agree. A study from Hungary's Konkoly Observatory estimates that Betelgeuse is still in the earlier helium fusion phase. The one thing scientists do agree on, despite these debates, is that Betelgeuse is destined to become the Milky Way's next supernova. But pinning down the timing of this event remains a cosmic guessing game, with estimates ranging from just a few years to 100,000 years. Amid these scientific discussions and speculations about Betelgeuse's fate, one truth remains unchallenged: the very nature of our observations. When we gaze toward the brilliant heavens, there's a subtle paradox we often overlook. This oddity is rooted in the nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes time to reach our eyes. For example, the speed of light, while a staggering 186,282 miles per second, still has its limitations. Thus, the light from distant stars and galaxies takes time to traverse the immensity of space before it graces our sight. Looking at Betelgeuse, you're truly seeing an exhibition from 650 years ago. To place that in context, when this light set out on its journey toward Earth, the Renaissance was unfolding, and explorers like Marco Polo were shaping history. Each observation we make of Betelgeuse is a glimpse into the past, a cosmic snapshot of an event that occurred long before we even saw it. This inherent time delay presents a unique challenge for astronomers. When we observe distant stars like Betelgeuse, we are looking at an image of the star as it was when that light was emitted. This means that when we observe Betelgeuse today, we're actually witnessing the star as it was in the 14th century, an important reminder that the universe is not only vast but also operates on a timescale far beyond human experience. As we continue to study Betelgeuse, its mysterious behavior invites more questions than answers. Will it truly go supernova in the near future? Or is it merely undergoing an extended period of instability? Whatever happens, Betelgeuse's fate remains one of the most fascinating phenomena in the night sky. We are on the precipice of witnessing something monumental, one of the greatest displays in the history of the cosmos, and perhaps a glimpse into the very mechanisms that drive the life cycle of stars. In the meantime, as Betelgeuse continues its dance in the heavens, astronomers will keep their eyes fixed on it, awaiting the next chapter in its dramatic story. Whether it's a sudden explosion of light, a slow fade, or something even more unexpected, Betelgeuse will undoubtedly continue to captivate our imagination for years to come. Its fate, and the secrets it holds, are bound to reveal a deeper understanding of the universe itself. For now, we can only watch and wait. The universe, it seems, has a way of reminding us that, despite our advancements, we are still very much a part of a vast and enigmatic cosmos, where even the most familiar stars can surprise us with their brilliance, mystery, and ultimate fate.